This is the experiment for VTOL, vertical takeoff and landing. Here it is considering of two loops. It has two loops. Inner current control loop and outer pitch control loop. Here we are going to do experimentally the inner current control loop using the transfer function. For connecting, we need to plug in the power cable to the ELVIS board. It is connected there, and we need to connect the power cable of QNET VTOL system, which is also connected using this, and we need to switch on the ELVIS board and then switch on the QNET board, and this is the data cable which will be connected to the computer. It is connected through USB. Now open the system. We can zoom in. Okay. Now open the system. In this ELVIS Quanser, open that folder. Go to VTOL, course resources, software, then current control. That is the inner loop which is of the VTOL system. This is the current control. The ELVIS board is registered in device 1. Choose device 1, enable current control. That is current control on. We should enable it. Enable the button, and then we can adjust the KPK values as per our wish. Let us say I am giving 10 and 100, and then we can run. From this we can see the system is tracking the current. The blue is the reference line and red is the actual motor current. And we can, to stop it, click stop. This is the next experiment using Quanser and with the ELVIS board, heating, ventilation and air conditioning HVAC system, where there is a fan. We are considering that fan is having uncontrolled speed, that is almost a constant speed airflow. These are the resistors, heating resistors. By giving the controlling the voltage across the resistance, we will heat it. That is I square R, the heat will be generated, and that will be passed through the full chamber using the fan. And these are the temperature sensors to sense the temperature. For our system, we are taking the average of all the temperature sensors as the room temperature. Now, similar to the VTOL, we will connect all the data. This is the powering circuit. This is the data cable. This is data to the PC. This is powering to the ELVIS board, and we need to switch on this one, and backside one switch will be there. Similar to the VTOL, open the switch on the computer, open ELVIS Quanser, go to HVAC, courseware resources, software. Here we will do both on-off control and PI control. First we are starting with on-off control. Here we need to ensure that the device 1 is selected, and we need to switch on heat on and off. Now this is VH amp and V off that determine the on voltage and off voltage. The on voltage is VH amp plus VH off, so our on voltage will be 8. Off voltage is V off minus V amp, so our off voltage is 0. If V off is 5 means 5 minus 4 it is 1. But if V off is 3 minus 4 is negative, that will not be happening. If voltage difference is negative, the off voltage will saturate at 0. And the delta TH is from the set point. If the temperature rises from 0 to 25 degree, it will transition from on to off, and we are giving the set point as 50. Now we will switch on the heat on and off, and we will start the simulation. Run. It is starting. The room temperature is around 38 degrees Celsius. Now it is switched on. As we can see, the sum of this 4 plus 4 is 8. The voltage across the resistors, heating resistors, are 8 now. Now temperature is rising and it is trying to reach 50. Now it crossed the 50, that is 50.25. It went to off position. Now off is 0 volts. the heat is slowly now reducing. Again, as it ready comes down, the heater is there is a resistors the system, and again it is switched off when it goes up and comes down. So from this we can see it is settled near 50 degrees Celsius, and we can, by adjusting this, we can change the bandwidth, that is how much distance we can oscillate in between the band. That band is determined by this delta Th value. So we can stop this for on-off control, and we can close this one. Now we are going for PI control. We open the PI controller. Here again, heat on and off we need to switch on, and anti-wind up on and off, it is we can switch on or off. That is if we are giving a very high reference value, this may not be able to track it. So we are switching on or off the anti-wind up. Let us say we are giving a 45 degree offset, 45 degree offset, and we are switching on. Since it haven't cooled down yet, it is starting at 50 and it is slowly reducing temperature. Now we can see the voltage increasing. It will be linear. From this we can see the system is tracking that temperature is maintained at 45 degrees Celsius, and we can see the voltage is continuous. It is not an on and off control, it is a continuous control. There will be a change in the reference, and we can see the system will be able to track that reference also. It will change the reference. The 1 minute it will change. Second it will change the reference. At 100th second, the reference will be changed, the blue line will be changed, and we can see if it is able to track or not. So I have given the amplitude as 5, so it will give plus 45 plus 5 and 45 minus 5 with a frequency of 0.01 Hertz. So it will change the reference soon, and then we can see the change in the tracking. Now we can see there is a change in the reference and it is trying to catch up to the change. Again it is tracking the reference and it is settling at that value.